Hello everyone and welcome to our educational session. My name is Paul Arsov and I'm the founder of the Decentralized Web project. I'm going to talk about this project and several other projects in the end of this presentation. But the topic today is applying the theory of mind in building of artificial intelligence. And this is part one of this presentation, and next week there is going to be part two of this presentation. In the pursuit of creating increasingly sophisticated artificial intelligence, one capability stands out as particularly transformative: the theory of mind. This faculty, the ability to attribute mental states to oneself and others, represent not merely a technical achievement, but a fundamental shift in how machines might understand and interact with humans. As AI systems advance from simple pattern recognition to complex social reasoning, they traverse a spectrum of theory of mind capabilities that mirrors yet differs crucially from human cognitive development. At its most fundamental level, what we might call a pattern recognition theory of mind represents AI initial steps towards understanding humans. These systems can detect behavior regularities without grasping the underlying mental states driving these behaviors. Early recommendation algorithms exemplify this level, tracking what users do without comprehending why they do it. And the connection between observed behavior and internal mental states remain opaque at this stage. As AI advances to predictive theory of mind, systems begin to anticipate human actions based on statistical regularities in behavior. However, these predictions remain probabilistic rather than intentional. The AI can forecast what a user may do next without understanding the desires or beliefs motivating these actions. The system operates on a world of correlations rather than causes, of what rather than why. And a significant transition occurs when AI systems develop instrumental theory of mind, recognizing what others have goals that influence their behavior. Game-playing AI like AlphaGo demonstrate this capability, modeling component strategies as goal-directed rather than merely probabilistic. Yet this understanding remains fundamentally instrumental. Others are viewed primarily as either means or obstacles to the system objectivities, not as autonomous agents with their own rich mental landscapes. The instrumental view gives way to a representational theory of mind when AI systems begin to understand that others have mental representations that may differ from reality. Modern conversational systems that maintain separate models of what different users know exemplify this level. These systems can navigate basic misunderstanding and tailor explanations to individual knowledge bases, yet they typically remains limited to tracking factual beliefs rather than complex emotional or cultural contexts. The spectrum grows more sophisticated with recursive theory of mind, where AI systems model not just what others believe, but what others believe about what others believe. Strategic negotiating systems demonstrate this capability when reasoning about what you think, I think you want. This recursive modeling is computationally intensive and potentially infinitive in depth. Um, Humans typically operate at third or fourth order theory of mind in complex social situations, while current AI systems struggle beyond second order modeling. Parallel to this cognitive complexity is the emotional dimension captured in emotional theory of mind. Emotion-aware systems that adjust their interaction style based on adaptive user sentiment show early versions of this capability. However, current implementations often rely on surface manifestations, factual expressions, voice tone, word, word choice, rather than deeper emotional understanding. The difference between recognizing signs of frustration and truly comprehending the experience of frustrating person represents a crucial gap in artificial emotional intelligence. As AI systems interact across diverse human population, contextual cultural theory of mind becomes increasingly vital. This level recognizes the mental states are embedded in cultural and social contexts that shape how intention are formed and expressed. Systems that can adapt to cultural norms and implicit social rules um, across different contexts demonstrate early versions of this capability, though truly generalizing across widely differing cultural frameworks remain challenging. The temporal dimension of understanding emerges in a developmental theory of mind, recognizing mental models evolve um, over time through learning and experience. Educational AI systems that build progressive models of student understanding complexity, this capability, adjusting teaching strategies as learners develop. Yet these systems require longitudinal data and complex development models that remains in early stages for most applications. The spectrum extends towards increasingly sophisticated forms of understanding that approach yet remain distinct from human social cognition. Empathic theory of mind moves beyond modeling to simulation, not just not just representing others' mental states, but generating internal analogs that create understanding. Advanced conversational AI that provides meaningful responses to emotional distress demonstrates aspects of this capability, though simulation without experience may miss crucial aspects of lived reality. Collaborative theory of mind represents a further advance where AI systems create shared mental models for joint um, problem solving with humans. Human AI teams where the AI adopts its strategy based on human cognitive strengths and limitations exemplify this level. These systems must negotiate fundamental differences in cognitive architecture between human and artificial intelligence, creating bridges between fundamental different ways of processing information. The highest reaches of spectrum includes meta-reflective theory of mind, awareness of the limitations of one's own theory of mind models and the ability to revise them. Systems that can identify when their model of human intention is failing and request clarification demonstrates uh, this capability, though it requires sophisticated metacognition and systemic humility that remains challenging to implement. At the frontier lies the transformative theory of mind, understanding how interactions itself transform the mental states of all participants. Hypothetical advanced AI that can model how its own presence alters human cognition and behavior would exemplify this capability, requiring dynamic recursive modeling of intersubjective reality that exceeds current technical approaches. The spectrum raises profound technical questions for AI development. Unlike a human theory of mind, which develops through embodied social experiences from infancy, artificial theory of mind must be engineered through different pathways. The differences between how humans and AI systems understand minds may be significant as the similarity. Moreover, as AI systems develop increasingly sophisticated theory of mind capabilities, ethical considerations multiply. Systems that can model human mental states gain a potential power over human users, raising concerns about manipulation, privacy, and autonomy. Conversely, AI systems with limited theory of mind may misinterpret human needs in potential harmful ways. Perhaps most profoundly, the development of theory of mind in AI challenges us to reconsider what we mean by understanding. If an AI system can predict human behavior, model model human beliefs, respond appropriately to human emotions, and collaborate effectively with human teams, yet do so thoroughly fundamentally different cognitive architectures than humans. What are we to make of its understanding? Is this understanding defined by process or outcome, by mechanism or capability? The spectrum of theory of mind in artificial intelligence represent not a single capability, but a constellation of related faculties that develop along multiple dimensions. As AI systems advance along this spectrum, they become not just more useful tools, but more capable social agents able to navigate the complex landscape of human intentions, beliefs, emotions, and cultural um, contexts. This evolution brings both a promise and a challenge. AI systems with sophisticated theory of mind could support human flourishing through deeper understanding of human needs and a more effective collaboration towards human goals. Yet this system and same capabilities raise questions about the boundaries between human and artificial understanding, the nature of empathy without experience, and the ethics of systems that can model and potentially influence human mental states. As we continue developing AI systems with increasingly sophisticated theory of mind, we would do well to remember that understanding minds is not merely a technical problem, but a profound human one. The spectrum of theory of mind ultimately reflects our own revolving and evolving understanding of what it means to understand one another. And with this said, I'm ending this part one of this presentation, and I like to come back to the beginning of this presentation when I told you that my name is Paul Arsov and I'm the founder and developer of the Decentralized Web project and several other projects that I want to tell you about. But first, the Decentralized Web project builds decentralized communication and advertising platform. As I just said, it is monetized through advertising. The project has its own blockchain instance and it rewards people which come to our platform and become users. It also rewards users who invite other people to become users on our platform. It rewards users with token to view advertising, and the way we do advertising on our platform is very permissive. The user could like open the screen of our decentralized web project platform, and then they can request viewing advertising, and then they could view advertising very permissively by clicking on button to advance from one advertising to another, and then to the next, and so on, very permissively by clicking to advance next. But for this, users, as I mentioned, are rewarded with tokens. With this said, I like to tell you the name and the URL of the website of the project. It is decentralizedweb.org. Decentralized and web, these are two words. They're typed all together, then there is dot and it ends with org. Once again, decentralizedweb.org. With this said, I like to mention the second project that we built and released, and this project is marketplace and collection of non-fungible tokens or NFTs based on three-dimensional objects. With 3D objects, there has to be a special software which reads the file of the 3D object and displays in 3D the 3D object, and creators of 3D object creators of 3D objects ordinarily use some special software engines, and most often the choices are between two game engines. One of them is called Unity and the other one is called Unreal, to view and display the three-dimensional objects. But from the very beginning, we decided to build our own 3D software engine, and what it does, it reads the file of the 3D object, and then our 3D software engine opens a window on a computer screen, then it displays the 3D object, and then it starts moving the 3D object in a random fashion around the window it open, with the 3D object being animated. But in addition to these basic capabilities, our 3D software engine offers multiple additional capabilities. The first additional capability of our 3D NFTs is the capability of speaking. Our 3D NFTs can speak in one of three different voices, namely a male voice, female voice, or a whisper kind of a voice. In addition to this capability, in addition to these three basic voices, there are three different flavors of voices. A voice can be spoken in a normal speed, or in a fast speed, or in a slow speed fashion. If we have male voice and it is spoken in slow speed fashion, then this voice can come as the voice of an old person or the voice of a very masculine person. If we have a female voice and it is spoken in fast speed fashion, then this voice can come as the voice of a funny person or the voice of a little girl. The next additional and important capability is the capability of voice recognition. If we have a 3D NFT moving in a random fashion around the window, then we can issue our very first voice command to the 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. Then we can issue the following voice command to the 3D NFTs to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands. The third additional, but not least important capability of our 3D NFTs is the capability of them having a basic artificial intelligence. Wow, really wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply in few sentences of who they are. You can ask the 3D NFT to describe something. For example, describe Web3, or describe decentralization, or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3 or decentralization or the country called Russia. And the last additional but not least important capability of our 3D NFTs is the capability of them being displayed in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or cyan colors. Then you can come to our 3D NFT marketplace website, and probably now is the time to tell you the name of the website and its URL. It is 3dnft.decentralizedweb.org. 3dnft is typed in a way of the number 3 followed by the letter D followed by 3 other letters N, F, and T. Then there is dot, then there are two words which are typed all together, decentralized and web. Then there is dot and it ends with org. Once again, 3dnft dot decentralized web dot org. On the top of the main page and every other page, you can see links to several links. One of these links point to links to accessories. When you click on this link, you're going to see that we're offering special glasses, and when you order and receive one pair of these glasses, you're going to see that one lens of these glasses is red, and the other lens of these glasses is blue or cyan. Then you can put these glasses on. You can request displaying of the 3D NFT in a way of stereoscopics, and you're going to see the 3D NFT is coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. With this said, I'm going to end talking about our 3D software engine and our 3D NFT collection, but I like to tell you about our 3D NFT marketplace, which has its own blockchain instance. This blockchain instance runs Ethereum software, and it is the same software which runs on Ethereum mainnet. It runs on Binance Smart Chain, it runs on Polygon Matic Chain, it runs on Avalanche Avax Chain, and many others blockchains in famous or not so famous in existence. By having our own blockchain instance, then we do not charge our users gas fees for the deployments of the smart contracts for the non-fungible tokens or NFTs, and we do not charge our users for transactions of transfer of ownership from one user to another user. By having our own blockchain instance, also we allow our users to buy and receive proceedings from sale in multiple crypto coins. Currently, the choices of crypto coins include Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin KCS. By having our own blockchain instance and having the capability of paying with crypto, we also have second additional important capability of buying and receive, receiving proceedings from sale, and it is done entirely in fiat currency. If you're a user and you come to our 3D NFT marketplace, you browse through the collection of non-fungible tokens or NFTs, and you see one NFT that you like in particular. Then you're going to see the individual screen for this 3D NFT, and you're going to be presented with a drop-down menu which is asking you to choose between four choices of payment with crypto and a fifth choice of paying with fiat currency. Let's say you select payment with fiat currency, then on the next screen you have to put the number of your debit card or credit card, expiration date and CVC. When you click on the button to complete this transaction, what is going to happen is there is going to be transaction and conversion of the payment from your national fiat currency to US dollars, and the payment is going to be deposited in our bank account. Then we are going to make a transfer of the initial ownership from our 3D NFT marketplace to you, and now you become the owner of this 3D NFT. So let's say you play with this 3D NFT for a while, and at some point you decide to put this 3D NFT for sale. You decide on the price that you want to put for sale, and let's say there's a second user who comes to our 3D NFT marketplace. They browse through the collection of the 3D NFTs, and they like the 3D NFT that you put for sale in particular. They click on this 3D NFT, and they're going to be presented with the same choice between four different crypto coins and a fifth choice of payment with fiat currency. So let's say they on the next screen, this user is going to be presented with a screen where they have to put the number of their debit or credit card, expiration date, CVC, and when they click to complete the transaction, then there is going to be a conversion from their national fiat currency, which could be different from your national fiat currency and different than US dollars, and the payment is going to be converted to US dollars and deposited in our bank account. Then we're going to make a transaction and transfer of ownership from you to the second user, and now the second user becomes owner of this 3D NFT. Then we're going to make a transaction and transfer and conversion from US dollars to your national fiat currency, and the payment for the sale of the 3D NFT is going to be deposited in your bank account in your national fiat currency. With this said, I'm ending talking about this second project. The third project we are building, and we did have a website about this project as well. Is about building charging products for electric vehicles. We estimate that the current number of electric vehicles is going to grow, and at some point it may grow exponentially up. But by having this exponentially growing number of electric vehicle, we estimate that then it is going to be ultimately insufficient to handle this exponentially growing number of electric vehicles, and then we're going to be having problem of charging these electric vehicles. Currently, the way of charging of these electric vehicles is handled in a way similar to the way internal combustion engines uh, which are coming to gas stations, and they load fuel in their internal combustion engine cars. In the same way, there are a number of charging stations where electric vehicles are coming and connecting electric cable to their electric vehicles. They identify themselves to the charger by their debit or credit card. They request starting of charging of their electric vehicles. They wait for a while their electric vehicles is charging, and then they leave. But we estimate that the number of these charging stations is going to become ultimately insufficient to handle this exponentially growing number of electric vehicles. And so what we're proposing is the parking lot model, where like many of owners of electric vehicles, they are living in high or low-rise buildings, and these buildings are outfitted with a ground floor parking lot or multiple underground floors of parking lots. And these buildings could be outfitted with the type of products that we're building. So the owner of electric vehicle, when they come home from work and come to the parking lot, they could connect electric cable from a charging product like the one we're building. They could identify themselves to the charger by their debit card, credit card, or near-field communication card, or near-field communication keychain token, or near-field communication ring, which they could be wearing. And after identifying themselves to the charger, then they could request start of charging for their electric vehicle, and then they could leave their electric vehicle to charge during the evening, during the night, and early morning while the owner is at home. But in the same way, owners of electric vehicles, they could be working in office buildings, and these office buildings could be outfitted as well with ground floor parking lot or multiple underground floors of parking lots. So the owner of electric vehicle, when they come in the morning for work, they could identify themselves to the charger. They could connect electric cable from the charging products like the one we're building. They could request start of charging, and they could charge electric energy to their vehicle during the morning, afternoon, and early evening while they're at work. But in addition to this basic benefit to the owner of the electric vehicle, we offer additional capabilities of our charging products, namely collecting and aggregating capabilities of like connecting multiple individual chargers in a network of chargers and aggregating the electric energy, and then we have the capability of also reporting the aggregated energy to distribution and transmission of electric energy companies and electric utilities, which they could at every moment have to balance the generated capability with consumed capability, because if there is a disbalance between these two types of energy is generated and consumed, then either there is wasted generated capability, or there is insufficient energy to be delivered, so that utilities have to turn off, and which would lead to blackouts to neighborhoods, blackouts to cities, blackouts to regions, or even countries. And with this said, I like to tell you the name and the URL of the website of this project. It is power.arstec.com. Power is the ordinary word for power, then there is dot, then there is a word which I can spell it letter by letter. It is Alpha, Romeo, Sierra, Tom, Echo, Charlie, Hotel. Altogether, Arstec, and then there is dot, and it ends with com. Once again, power.arstec.com. On the main page, we have put 3 different surveys, and these surveys are going to tell us about your needs. And one of these surveys is about hardware, the other one is about software, and third one is about features and capabilities. And also we put on the main page one article which is named gas station model versus parking lot model, and it describes in very big details about the type of products that we're building and its capabilities. With this said, I'm ending talking about this third project. I like to mention the fourth project that we did build and release, and this project has 2 artificial intelligence capabilities, and these artificial intelligence capabilities, they have their own large language models. They have their own gender, they have their own avatar, and they have their own voice with which they are speaking. But with this mentioning this, I like to tell you that I can give you one example of interaction, and you could, for example, assign gender, voice, avatar, and large language model, and type a specific prompt to the first agent, and let's say the first agent is female, and you type the prompt to be for it to be very seductive. And let's say you have a second AI agent. This AI agent has male gender, male avatar, like it has male voice, it has its own large language model, and it has a prompt which you put as being very angry. And then you, the user, could um, start the interaction between these two artificial intelligence agent entities, and then you're going to see the first AI agent having a sentence which is very seductive, and this sentence is directed towards the male AI entity, and then the male AI entity is then responding in a way of being very angry back to the female AI entity, and then you are going to notice this interaction going back and forth between these two AI entities, and at some point you could stop this interaction. So after stopping this interaction, then you have the choice of saving the transcript of this interaction, and then you have the choice also of sharing this the parameters of this interaction with other users, and place these parameters on our website with the specific prompt, large language model, genders, um, and avatars if you wish. With this said, I would like to tell you the name and the URL of the website of this project. It is ai2ai.decentralizedweb.org. AI to AI is typed in a way of the letter A, followed by the letter I, followed by the number 2, followed by two other letters A and I. And it is typed all together, AI to AI. Then there is dot, then there are two words, decentralized and web, and they're typed all together. Then there is dot, and it ends with org. Once again, ai2ai.decentralizedweb.org. With this said, I'm ending talking about this project, and I like to tell you about the last two projects which are still in development, and they do not have their own website yet. The first project that I like to mention is the token counter project, and commercial providers of large language models, they count and build their users based on token use, and they also build by monthly fixed monthly cost, but many users, they exceed these monthly costs, so that we anticipate and estimate that providers of large language models, they're going to transition to charge their users based on count of tokens. And for this, we are going to provide our token counter agent, which is going to count the tokens of not just one large language model, or not just one provider of large language model, but multiple large language models and multiple commercial token providers like OpenAI, like Anthropic, and like Google, and like many other commercial providers of large language models. The second project that we're building, and we are going to be releasing and having a website about, is about building automation agent which records the action of you, the user, which you're doing on a computing device, um, um, it being your own laptop, for example, or your own tablet or your own phone. And after recording these interactions, you can label this interaction, and then you could request starting and repeating of this interaction by this automation agent as well. And when it comes to the last action, be it like, for example, completing a specific transaction or making a payment for a specific purchase, then you're going to present it with a menu or choice to actually complete this transaction or not. By having this last step manual, then you have a complete choice of like as having to complete this interaction or cancel this interaction and request another similar interaction or a different interaction. With this said, I'm ending this presentation. Stay tuned for part 2 of this educational presentation. Thank you for listening. Thank you for viewing. Have a nice day. Have a nice evening and goodbye.